This video is going to talk about atomic structure and how that relates to the periodic table. So first, let's talk about what we know about atomic structure. Atoms are neutral. They don't have a charge. When you hear the word atom, it means it's neutral. There's a different word that you're going to learn later if an atom does have a charge. But right now, know that all atoms are neutral and they have no charge, and that's because they contain the same amount of positive charges, called protons, as they have negative charges, and those are electrons. Because those two subatomic particles are equal, it makes the atom neutral, same number as positive as negative. An atom is made up of 3 parts called subatomic particles. And your 3 subatomic particles are shown here. You have protons, neutrons, and electrons. So protons, you will also see this symbol, P with a plus sign for proton. Neutron, you'll see a lowercase n with either a 0 or a 0 with a slash through it to be a neutron. And electrons will be a lowercase e with a minus sign. And those are the symbols that go with those. And that really helps to explain their charge as well, because protons are positive. We find them in the nucleus and they're positively charged. Neutrons, the 0 with the line through it, they don't have a charge. Neutrons have no charge, and we can see them in the nucleus as well. So these 2 particles are in the nucleus. Electrons have a negative charge, hence the minus sign next to them, and they are found around the nucleus. And when they're around the nucleus, they are actually in the electron cloud. They're in probable locations. And so our diagram here, this is a Bohr model of the atom, and you've learned about Bohr's model, the solar system model. And it does a good job to show generally what's happening. However, know that his model was proven to be incorrect to a degree. Electrons don't just orbit the nucleus like cars on a track. They are in probable locations in the electron cloud. Let's talk more about the nucleus. The nucleus contains the mass of the atom, and that is what is special to the nucleus. This is the mass of the atom, and this picture is deceiving because it doesn't show the particles to their actual size. A proton and neutron are about the same size, but electrons are so small, just so small. They barely have any mass whatsoever. So it's a little misleading to see them all as the same size, but the electrons are significantly smaller, so they don't really contribute to the mass. All of the mass of the atom comes from the nucleus. However, the nucleus, though, doesn't really contribute to the volume of the atom because it's so small. It's so small and has a high mass, but it doesn't take up a lot of space. So the mass of the atom comes from the protons and neutrons because they make up the nucleus. Just to give you an idea about size of what is going on between the nucleus and the electrons, if an atom was the size of a football field, the nucleus would be like a BB, so small on the 50-yard line, and the closest electron would be way up in the stands. And we're not talking about like a high school stadium, we're talking about a professional stadium. So there's a lot of empty space in there. So based on what you know about charges, and that like charges repel and opposites attract, you might be looking at the nucleus wondering how it stays together, because we only have positive and neutral charges. So the reason this stays together and all of those positive charges are able to be in there together is because of the strong nuclear force. So the strong nuclear force is responsible for holding our nucleus together. It is the strongest force in the universe. Sometimes we might think that gravity is the strongest force in the universe because it holds us down to our planet, but it's actually not. Gravity is the weakest out of the 4 fundamental forces. The 4 fundamental forces are the strong nuclear force, weak nuclear force, gravity, and the electromagnetic. So the strong nuclear force is the strongest, as the name would assume. But even though it's the strongest, it only acts across really short distances. So it's only across short distances, like that of a nucleus. Next, let's talk about the electron cloud. The electron contains the volume of the atom, but it doesn't really contribute to the mass of the atom. That's because electrons don't really carry a mass with them. It's very, very small, very insignificant. But where they're in this cloud region all the way out here, that takes up a lot of space, so they contribute to the volume. Just to give you a size perspective, think about a copper penny. There are about 24,900 quintillion atoms of copper in one copper penny. That is a lot of atoms just in one copper penny. The next thing you're going to do is you're going to make a foldable. So you can pause this video as you're going and creating your foldable. The outside of your foldable is going to look like this. So you're going to take a piece of paper and fold it in half long ways, just like this. And then you're going to cut 6 tabs in it, but only cut through the top layer, so that way you can write on the bottom layer. You can also hole punch the sides and keep it in your binder. So you're going to label those 6 tabs: atomic number, mass number, protons, neutrons, electrons, and average atomic mass. We're doing a foldable because it's a really great way to organize your information as well as be interactive. And so just by opening up the foldable and turning the tab, you're engaging a different part of your brain. So it's a really excellent thing to do. Once you have the outside of it made, you're going to make the inside. And so this tells you what to go on each tab. I drew some lines on the inside of mine to help divide up where things were, so it was easier for me to see. So you're welcome to do that too. But you're going to go number of protons plus number of neutrons, atomic number, mass number minus atomic number, number of protons, and then decimal on the periodic table. I would recommend keeping this out as we go through the rest of the lesson, and you guys are always welcome to use this foldable if you need it. Speaking of using the foldable, we are now going to use it for some guided practice with different notations. So we're going to practice calculating the protons, neutrons, and electrons for different elements. So you're going to need a periodic table, so go ahead and get a periodic table out. You can use the one up on the wall, but keep in mind that one doesn't have names, it only has symbols. So we're going to go through the first example together and talk through some of these. First one, we just have the element. So let's find Cl on the periodic table. Okay, we found it. Cl is right here on the periodic table. The next thing I need would be the atomic number and the mass number, but I'm going to round this mass number here so that I have a whole number. We never want to have a decimal when we're figuring out the number of neutrons because it'll mess up our calculation. So 17 is the atomic number, and then 35.453 rounds to 35. So our mass number will be 35. Now we're going to fill out the rest of this. So if you look at your foldable under protons, we'll notice that protons are equal to the atomic number, which means this column and this column are always going to be the same. And we know the number of electrons is the same as the number of protons, so that is going to be the same as well. The next thing we need to do is figure out the number of neutrons. To figure out the number of neutrons, our foldable says take the mass number and then subtract the atomic number, which means we're going to take 35 minus 17 to get an answer. And if you don't want to do mental math, you're welcome to grab a calculator. And our answer is 18. We have 18 neutrons. This next problem is a little bit different. You'll notice that you're given the number of protons, and then you have to fill out the rest. So we know that the number of protons is equal to the atomic number, which means these are going to be the same. And we know that protons are equal to the number of electrons. So now we can find something that has an atomic number of 27. So let's take a look at the periodic table. So we're searching for an atomic number, this top number of 27, and we find it right here. It is cobalt. So our symbol is going to be CO. Our mass number for this one is 58.93, which we're just going to round to 59. Let's fill that out. The last thing to do is figure out the number of neutrons. Number of neutrons is mass number minus atomic number, so 59 minus 27. And our answer is 32. Let's move on to some different notation. So this notation is called nuclear notation because we use this when we're balancing nuclear reactions, which you're going to do later this unit. We see 10847 Ag. So let's go ahead and figure out what each of these numbers mean. So silver, Ag, is right here. Its number is 47, which means this is the atomic number. And 108 is going to be the mass number. So in order with this sort of notation, we have the mass number, the atomic number, and then the element. So I like to call this max, and we're going to write this down too. Where the M stands for the mass number, A stands for the atomic number, and X would be whatever element symbol you have. So this is max notation. Okay, so our first one, the atomic number we said is 47, and the mass number is 108. We know that the atomic number, the protons, and the electrons are all going to be the same, so we can quickly fill that out. Next, for the neutrons, it'll be the same exact thing. We're going to take the mass number minus the atomic number, so 108 minus 47. And we get 61. Okay, let's try the next one on your own. So take a second and try to solve for the protons, neutrons, and electrons. You found that the protons were 55 and the electrons were 55. In order to get the neutrons, you said 133 minus 55 will give me neutrons, and you got 78. The last piece is to write it as nuclear notation. So we know that mass is on top, atomic number is on the bottom. So mass number is 133. Atomic number is 55. The next thing we need to do is figure out the element symbol. We're going to go to the periodic table and we're looking for number 55. 55 is right here. Our element is cesium and the element symbol is Cs. So we'll write Cs. And that one is done. There's one more type of notation that you need to be familiar with, and it has a couple different names. It's called isotope notation, and sometimes it's called hyphen notation. That's because you will always have the element name followed by a hyphen, very creative name, and then you will have the mass number. So this number after the hyphen, that is your mass number. Now, very important to note, the number after the hyphen might be different than what's on the periodic table. That is fine. Use the number that is here. Don't use the periodic table number in this case. Use the number that is here instead. Let's work through the first one together and then have you try the second one on your own. So the atomic number for calcium, we're going to have to look up, but we know the mass number is 40. So let's go find calcium on the periodic table. Calcium is right here. It's number 20. Then we can fill out the rest of it. We know atomic number, protons, and electrons are the same. And now we just have to solve for neutrons. And neutrons, we take the mass number minus the atomic number, 40 minus 20, and we, of course, get 20. Go ahead and try the next one on your own. All right, let's go over this. So protons are 83. That means atomic number and number of electrons are 83. To figure out the mass number then, what we can do is we can add the protons and the neutrons together. Because the mass number minus atomic number gives us neutrons, we can just use that equation backwards and say, well, we're solving for the mass number, and we can add the atomic number or the number of protons to the other side. So 83 plus 126, that is 209. Now let's figure out what element this is. Number 83 is bismuth. It does work out nicely this time that the mass number is the same as the periodic table. However, that will not always work out with hyphen notation. So we have bismuth, 209. The last thing I want to write down, and you can write this down off to the side somewhere, and it has to do with the subatomic particle that defines the element. So we notice on the periodic table that the number in the top corner is the one that always tells us what element that is, and that's the atomic number. The reason that one is used is because that is always equal to the number of protons. So when you see this number in the top corner, really be thinking, oh, this is actually the number of protons. So the number of protons is defining that element, not the name, not the mass. It's this number that's the number of protons. It does happen to be the atomic number. That's great. But the point is, it's the number of protons that defines the element. Let's jot that down. So the number of protons defines the element, and you can bet that is going to be a test question. All right, just to recap, you guys now know the basics of atomic structure, that atoms are neutral. They have 3 parts. In the center, you have the protons and neutrons that make up the nucleus. The electrons are going around them in the electron cloud. You have some perspective for the size of an atom, which is so small. You made a foldable, and you can use that whenever you need to. And then we did some practice with different notations, looking at just the symbol and using the periodic table, using nuclear notation and isotope hyphen notation. That is it for atomic structure.